Is the board visible, everyone?
Yes, sir.
Right. So let us start motion in a plane. Hopefully, I'll try to give the entire review of motion in a plane in today's session. And it would be a 1 hour session only, guys, today. And tomorrow we'll take some extra time in the evening, right? And on Sunday we can have a little bit of lengthy session, guys. That too in the morning. Okay. So let us see how things will turn around. I hope the board is visible to all of you. Right. So in the last session or last two sessions, we were discussing about the motion of an object in a straight line. Either it was along x-axis or it was along y-axis. Right. So in today's session, we will be just discussing how will the motion be in a plane. Now, when I say a plane surface, how do you basically visualize a plane surface, guys? If we are sitting in a room, the front wall and the back wall, these are vertical planes, xy planes. The side walls, these are also vertical planes, but YZ planes. The floor and the ceiling, they are going to be horizontal planes. These are XZ planes. Planes, any plane surface you take, usually you can visualize it with the help of walls again, guys. Front wall, back wall, XY plane, side walls, YZ plane, right? And the floor and the ceiling will be your horizontal planes, which are your XZ planes, guys. So in this chapter, from this chapter onwards, we start vectors again, basically. So if we just see what is a scalar, it is any quantity that is, it is any quantity which is determined only by magnitude again, right? These are described by their magnitude only, only magnitude. Such quantities will be called as scalar quantities. And those quantities which are described by both magnitude as well as direction, those will be called as vector quantities. Okay. So again, if there is a direction, right, if there is a physical quantity which has a particular direction, let us say current has a particular direction, it always flows opposite to the direction of electron. Although current has a particular direction, it is not a vector quantity. Why? Because it does not obey laws of vector addition again. Okay. So if a quantity has both magnitude and direction, can I say it is a vector quantity? No, it is not necessary that it is going to be a vector quantity, guys. For it to be a vector quantity, it has to obey the laws of vector addition also. Clear, all of you? Yes or no?
Yes.
Right. Let's try to understand. So scalar is that quantity which is described only by magnitude. Vector is a quantity which is described by both magnitude as well as direction. Now, one very important thing which you need to understand is, right, even though a quantity has magnitude and direction, still it is not necessary that it should be a vector quantity. For it to be a vector quantity, it has to obey laws of vector addition. Basically, triangle law, polygon law, parallelogram law, those cases. Now, what are the different types of vectors if we see? First vector happens to be a unit vector. Unit means one, guys. So that particular vector whose magnitude is one, unit magnitude will be called as a unit vector, guys. So suppose if a bar is a vector, what will its corresponding unit vector be? A cap will be its unit vector. Okay, and how can I write vector as? Any vector can be represented, it should have both magnitude and direction, yes or no? So this will be magnitude of a bar. Direction will always be given by unit vector again. So any vector can be represented as magnitude. So this will give us the magnitude. This is going to give us the direction. So what does unit vector represent? Unit vector always represents direction. Clear? For a vector to be defined, it should have both magnitude and direction again. Clear, all of you? So as you can see, unit vector along a direction is always unique. Okay. So how can I represent unit vector? Unit vector now, a cap can be represented as a bar divided by magnitude of a. It's a very important case again. Any vector can be represented as magnitude of a into a cap. A cap can be given as a bar divided by magnitude of a. Very important case. So I cap will be 1 unit along x-axis. J cap will be 1 unit along y-axis. K cap will be 1 unit along z-axis. Clear, all of you? Yes or no? What is the meaning of plane you have understood? What is the meaning of plane? Did you understand, guys? Any plane surface. Walls you can consider. These are all your planes only. Okay. Now, when we talk about the next type of vector are called as coplanar vectors. What is the meaning of coplanar vectors? Those vectors which lie in same plane. What are they? They're going to lie in same plane. So either you take two fingers, you should place it in front wall, you should place it in back wall, to the side walls, or on the ceiling and the floor. If they both are lying on the same plane, in the same plane, then only we can say they are going to be called as unit vectors again. Clear, all of you? Yes or no, everyone? Right. Although this is related to maths, guys, let us not go in detail about this, but please do remember for three vectors a bar, b bar, and c bar to be coplanar, their scalar triple product a bar dot b bar cross c bar should be equal to 0. Right? B bar cross C bar, if I take, let us take two vectors in a front wall. This is B bar, this is C bar. So if I do B bar cross C bar, I'm going to get perpendicular to the wall. A bar is lying in the wall. B bar cross C bar is perpendicular to the wall. Whenever you do dot product of two vectors which are perpendicular to each other, the dot product will be 0. Okay. So please do remember coplanar vectors are those vectors which lie in same plane. Unit vector is a vector which has one magnitude as 1, and it is used to identify the direction of the given vector. How can it be represented? It can be represented as a bar divided by magnitude of a. Understood? Yes or no? So basic things again, when we talk about parallel vectors, you all know if two vectors have same direction, they are parallel vectors. If two vectors have exactly opposite direction, they are anti-parallel vectors, right? And null vector is that particular vector which doesn't have any magnitude, and you cannot specify the direction of null vector. Null vector is simply written as point again. Can point have direction? No. So null vector cannot have a specific direction. Clear, all of you? What is scalar? Physical quantity which is described by only magnitude. What is vector? Described by both magnitude and direction. Suppose if a physical quantity is described by both magnitude and direction, is it necessarily vector? No, it is not necessarily a vector. When will it be a vector? If it obeys the laws of vector addition. Exception cases, example is current, guys. Current has a specific direction. It always flows from higher potential to lower potential, or opposite to the direction of flow of electrons. Right? It has a specific direction, but even though it has a specific direction, it is not a vector quantity because it does not obey laws of vector addition. I hope it is clear, all of you. When I say laws of vector addition, there are three types of laws, guys. What are those three laws? The first law happens to be triangle law. Triangle law of vector addition. What is triangle law stating? Again, any vector can be represented by an arrow. Very basic logic, guys. If I take a vector a bar, it can be represented by an arrow. This will be tail, this will be head. The length is going to give us magnitude. This part, the length of the vector, will give us magnitude of the vector. Similarly, the arrow mark, this arrow is going to represent the direction. So any vector can be represented by simply a arrow again. So what is triangle law stating? So two vectors are given. A bar is given, B bar is given. If two vectors are represented by two sides of a triangle taken in same sense, you see a bar is taken from head to tail, sorry, tail to head. B bar also tail to head. So if two vectors are represented by two sides of a triangle, resultant will be represented by the closing side taken in opposite sense. You see a bar tail to head, B bar also tail to head, but R bar is taken from head to tail, guys. So if two vectors are represented by two sides of a triangle taken in same sense, then the resultant will be represented by the closing side. That is your triangle law. Then we have polygon law. What is polygon law stating? If you have n number of vectors, if they are represented by n sides of a open polygon taken in same sense, then the resultant will be represented by the closing side taken in opposite sense. Same like triangle law only. But for triangle, you have three vectors only. For polygon, minimum three vectors. You may have four, you may have five, you may have six. Right? So suppose if I take n vectors, three vectors I am taking. A bar, B bar, and C bar. So if n vectors are represented by n sides of an open polygon taken in same sense. You see, tail to head, tail to head, tail to head. But if you look at the resultant, how is the resultant taken, beta? It is taken from head to tail, and it is represented by the closing side. So if n vectors are represented by n sides of an open polygon taken in same sense, resultant of those vectors will be represented by the closing side taken in opposite sense. Clear, all of you? How triangle law is nothing but basic polygon law. Okay, triangle law is nothing but basic polygon law. Or if you upgrade triangle law, you will get polygon law. Did you understand? Then we have another law of vector addition. Am I audible, everyone?
Yes, sir.
We have another law of vector addition called as parallelogram law of vector addition, guys. What is parallelogram law stating? If two vectors are represented by two adjacent sides of a parallelogram, then the resultant will be represented by the diagonal contained between those two adjacent sides. So in vector form, we can write r bar as a bar plus b bar. But what would be the resultant, guys? Very important case again. The resultant magnitude will be given as under root of a square plus b square plus 2ab cos theta. What is theta here? Theta is the angle between a bar and b bar. What is it? It is angle between a bar and b bar. So whether you take triangle also, this only will be magnitude, guys. Okay, magnitude of two vectors will be given as under root of a square plus b square plus 2ab cos theta. You can also find tan alpha and tan beta, which are not that much necessary, guys. Okay. Suppose if both a and b are same vectors, guys, right? If both of them have same magnitude, so basically, how will you write resultant of two vectors? I can write magnitude of resultant as simply r. It will be under root of magnitude of a bar square plus magnitude of b bar square plus 2 into magnitude of a, magnitude of b, cos of angle between the two vectors, guys. So I can simply write it as a square plus b square plus 2ab cos theta. This is the magnitude of the resultant, beta. When two vectors a bar and b bar are being added, the magnitude of the resultant will be under root of a square plus b square plus 2ab cos theta. Now what they have mentioned, if a and b are equal, means magnitudes are equal, guys, then what will I get the resultant as? I'm going to get the resultant as, so will you get it as a square plus 2a square cos theta? 2a square into 1 plus cos theta you are going to get, which will be 2a cos theta by 2, or I can write it as 2b cos theta by 2. If two vectors which are being added have same magnitude, then the resultant can be written as either 2a cos theta by 2 or 2b cos theta by 2. Is that clear? Yes or no? So maximum value of the resultant will be sum of the magnitudes of individual vectors, and minimum value will be given as difference between the individual vectors, guys. Okay, and always remember, right? So resultant, if both of them have same magnitude, resultant is 2a cos theta by 2 or 2b cos theta by 2, you can write. And maximum value of r will be a plus b, minimum value will be a minus b. Always remember one more very important case, guys. If I take resultant of two vectors, resultant of two vectors will always lie between a difference b and a plus b. Will always lie between a difference b as well as a plus b. Is that clear? Yes or no? Also, one more very crucial point again. If both magnitudes of a and b are equal, and it is equal to the resultant again, what I can write in that case, theta value will be 120 degrees. Okay. Understood, all of you? Yes or no? So rest all we can remember again, but basic things you need to know. Whenever we are taking either triangle law or I am taking parallelogram law, in both triangle and parallelogram law, we will take two vectors. In triangle law, if two vectors are represented by two sides of a triangle taken in same sense, resultant will be represented by the closing side taken in opposite sense. In parallelogram law, if two vectors are represented by two adjacent sides of the parallelogram, then resultant will be represented by the diagonal contained between these two adjacent sides. Magnitude of resultant will be a square plus b square plus 2ab cos theta under root. If both the magnitudes are same, then resultant can be written as 2a cos theta by 2. And always remember, resultant will lie between a minus b as well as a plus b, or a difference b and a plus b. Understood? And what they are saying, if the resultant has same magnitude as that of a or b, then angle between the vectors will be 120 degrees. Clear, all of you? Yes or no? And one more very important thing that you need to know is, in polygon law, suppose if given vectors, let us take a bar, let us take b bar, let us take c bar, let us take d bar, let us take e bar. So how many vectors I have taken, beta? See, tail to head, tail to head, tail to head, tail to head, tail to head. How many vectors did I take? A bar, B bar, C bar, D bar, and E bar. Are the given vectors forming a closed polygon? Yes. So whenever given vectors are forming a closed polygon, the resultant vector will be a null vector, guys. That is the last point again, which is given. Understood, all of you? If vectors are represented by sides of an open polygon, then resultant will be closing side. But if the vectors given are itself forming a closed polygon, then resultant vector will be a null vector, guys. Clear, all of you? Yes or no? Clear, everyone? Am I audible? Hello?
Yes.
Hey, are we connected? Now, when you talk about subtraction of two vectors, subtraction of two vectors majorly will deal with addition of two vectors and negative of a vector, guys. Okay. So let us not deal much about this, but basically you'll get the magnitude as under root of a square plus b square minus 2ab cos theta again. Okay. So vector subtraction is concept of vector addition. It is just concept of vector addition plus negative of a vector. What is the meaning of negative of a vector? That particular vector which has same magnitude but exactly opposite direction will be called as negative of a vector. So I can obtain vector subtraction by vector addition as well as using the concept of negative of a vector, which is not that much necessary again. Let us talk about resolution of vectors, guys. It's very simple. Length will represent as magnitude, as you all know. So I have taken a vector in xy plane, as you can see, right? So what I'll do, I will drop this vector on x-axis to find which component? X component. I will also drop this vector on y-axis to find which component? Y component. Can you drop this vector on z-axis? No, because it is lying in a plane. Plane will contain two perpendicular directions. You cannot take a third dimension in a plane, guys. So if a vector is taken in xy plane, I will have x component and y component. If I take a vector in yz plane, I will have y component and z component. If I take a vector in xz plane, I'm going to have x component as well as z component. Is that clear? What will length give us? Length will give us magnitude or not? For theta, what is this side? Adjacent. So what I'll write, beta? It will be v cos theta. This side for theta, what is it? This and this side are equal or not? So what is this side here? It will be v sine theta. So if we talk about v bar, it contains two components, x component as well as y component. How will you write x component as? It has v cos theta units along positive x direction. Direction will always be given by unit vector, guys. So v cos theta I cap plus how many units it has along y direction? V sine theta, it has along j cap again. So I can write V into cos theta I cap plus sine theta j cap. Is that clear, all of you? Yes or no? Resolution of vectors is very important again. For theta, this side is adjacent. So adjacent will always be represented in terms of cos. For theta, this side is opposite. So opposite will always be represented in terms of sine. Understood? How many components can a vector have? How many components can a vector have?
Two.
Again, a vector can have infinite components, guys. Vector can have how many components? Infinite components. But it can have two perpendicular components in plane, three perpendicular components in three-dimensional space, four perpendicular components in four-dimensional space, five perpendicular components in five-dimensional space. But in general, how many components will a vector have, or can a vector have? It can have n number of components, infinite components it will have. Clear, all of you? But if you take in plane, it will have there is a difference between component and perpendicular components. In a plane, how many components can a vector have? Infinite. How many perpendicular components can a vector have? Two perpendicular components, guys. Clear, everyone? Yes or no? That is how we resolve a
What's
vector.
the difference between component and perpendicular component?
Component, there is no necessity that components have to be perpendicular, but rectangular component should definitely be perpendicular. So I can take two components which are inclined to each other by 30 degrees, 60 degrees, 45 degrees, but perpendicular components should definitely be perpendicular to each other. Okay,
Yes.
understood. Now in vectors, very major role will be played by scalar product, is also called as dot product, and vector product, guys, also called as cross product again. So first let us see dot product is very simple again. Now whenever we have two vectors, and this is also called as multiplication of vectors, guys. I will not write. So whenever we have two vectors, guys, if we are doing dot product, a bar dot b bar, I can write it as a into b cos theta. Okay, and always remember, if two vectors are perpendicular, if a bar and b bar are perpendicular, then what I can say, their dot product will be 0. Always remember, for two perpendicular vectors, dot product will always be 0. Clear? In the same manner, also remember, I dot I will be j dot j will be k dot k will be equal to 1. Right? Scalar product, anyhow, it is going to obey commutative law as well as distributive law. It is not that much essential again. Clear, all of you? Yes or no? And how can I write cos theta as here? So we got dot product of two vectors. If I take two vectors a bar dot b bar, what will it be? Magnitude of a, magnitude of b, cos theta. If I want to find cos theta, which is angle between the vectors, I'll write it as a bar dot b bar divided by magnitude of a, magnitude of b. So what is theta? Theta is the angle between vectors. It is given as a bar dot b bar divided by magnitude of a, magnitude of b. Clear, all of you? Dot product. Whenever we are performing dot product, the resulting quantity will be a scalar quantity only. Understood, everyone? Yes or no? So always remember, two perpendicular vectors, if you are taking, their dot product will always be 0. Understood? I dot I will always be equal to j dot j will always be equal to k dot k, which is 1. However, I dot j 0, j dot k 0, k dot I 0. Why? Because they are perpendicular components again. Understood, all of you? Right? Cross product, if I take, how will you perform cross product again? Previously we have seen dot product. Let us see cross product, guys. When I write a bar cross b bar, it is written as magnitude of a, magnitude of b, sine theta n cap, guys. Okay, so you see, this will represent as magnitude, but n cap will give us what? Because it is a unit vector, will it give us direction or not? Yes, it is going to give us direction. So whenever we obtain cross product of two quantities, in the result, am I going to get both magnitude and direction? Yes, I am going to get both magnitude as well as direction, guys. Right? So that is the reason whenever you perform cross product of two vectors, the resulting quantity will again be a vector quantity only. Okay. So as I said, this is the magnitude again. So I can write magnitude of A bar cross B bar as A into B sine theta. And what is n cap? It gives us the direction of A cross B. So if I take n cap beta, what will I get? I have A bar cross B bar divided by what is AB sine theta now? Is it magnitude of A bar cross B bar or not? This is how we are going to get something called as unit vector, guys. What is unit vector? Whose magnitude is what? 1, and it will give direction. So what will n cap give us here? N cap gives us direction of what beta? A bar cross B bar. It gives us direction of A bar cross B bar. It is also one more very important point, guys. It is also a unit vector. Is also a unit vector perpendicular to both A bar and B bar, guys. Perpendicular to both A bar and B bar. Understood, everyone? Cross dot product was given as directly AB cos theta, but cross product will be given as AB sin theta, and n cap also we will take. So what is n cap here? It is going to give us direction. AB sin theta will give us magnitude. Understood, everyone? Yes or no?
Yes.
What do you need to remember is we need to remember cyclic rule here, guys. I dot j dot k rule you should remember. Whenever we are doing I cross j, it will give k. Whenever we are doing j cross k, it will give I. If you are doing k cross I, it will give us j. This is very important. And whenever you do cross product of two vectors which are parallel to each other, then there won't be any dot product. There won't be any cross product. Dot product will be there. Understood, all of you? See, very important case. Cross product of a vector with itself is a null vector. Understood? In the same manner, very important case. The magnitude of cross product of two vectors. What does it give? Area of parallelogram. So whenever two vectors are forming a parallelogram, then in that case, what will the magnitude of their cross product give us? It will give us the area of the parallelogram, guys. Clear, everyone? Cyclic rule, I hope you can remember. I j k, I cross j k, k cross I j, right? J cross k I. Okay, is that clear? Yes or no, yaar?
Yes.
Sir.
Right. Let us perform how to see. Suppose if a vector is given in plane. In plane, how many components does the vector have? जी sir, बताइए. How many components does the vector have in plane? Components I said infinite. Rectangular components two, guys. So I can write ax I cap plus ay j cap. Okay. And b bar let us take. What we can write? Bx I cap plus by j cap. So let us say I want to perform dot product of these two. A bar dot b bar. So what I'll get? I'll directly write ax bx plus ay by. Clear, everyone? A bar is given as ax I cap plus ay j cap. B bar is given as bx I cap plus by j cap. Then I'll write directly a bar dot b bar as ax bx plus ay by. Is that clear? Now, if I want to find cross product, what I'll do is I'll use determinants concept, guys. I am doing A cross B. What is first vector? A bar. What is second vector? B bar. So because I have taken vectors in plane only, guys, so I'll take only two rows and two columns. The first vector, what are these? Ax and Ay. Second, what will you have in second row? Bx and By. So how will you perform? We are just going to play crisscross, guys. So what are we going to get? We are going to get ax by plus ay bx. This will be our cross product. I'm not saying it is cross product, it is magnitude of the cross product, guys. Understood? The magnitude of cross product is found by using determinants. Whereas dot product directly you can do ax bx plus ay by plus az bz plus some other components, guys. However, cross product should be done in this manner. I hope you understood. Yes or no? So I have taken vectors in plane. Let us see how to perform cross product in vectors while vector is taken in space, guys. So while vector is taken in space, how many components will a vector have in space? How many components will a vector have in space?
3. In components.
No, infinite components. How many perpendicular components? 3. So that is the reason if you take a bar, as you can see, a bar is represented as axi cap plus ayj cap plus azk cap. Okay. Similarly, b bar is also represented as bxi cap plus byj cap plus bzk cap. Yes or no? Now, if you do dot product of this, what will you get? You will directly get ax bx plus ay by plus az bz. Yes or no, everyone? However, if you want to do cross product with 3 perpendicular components, then what I'll do? In first row, I'll write I, J, K. In second row, I'll write AX, AY, AZ. In third row, I'll write components or elements of the second vector, BX, BY, and BZ. So how to do this multiplication, guys? Very simple. If I want to find X component, I'll take I cap, block first row and first column, or block the row and column in which I cap is present. What will I get? AY, BZ minus AZ, BY. Yes or no? I don't think it is visible here. So how can we perform crisscross, guys, again? If you want to find X component, I will block the X component. Right? What are the elements left out? AY, BZ minus AZ, BY. You see, did I get AY, BZ minus AZ, BY? Yes. Similarly, I want to find J component or Y component. What I'll do? I'll block column and row. What I'll get? AX, BZ, AZ, BX. See, AZ, BX minus AX, BZ. But here, for this coefficient will be plus, for this coefficient will be minus, right? For this also coefficient will be plus. Clear, all of you? In the same manner, I want to find Z component. So in order to find Z component, what are we going to do? We are simply going to block the column and the row in which Z component is present. So what are the elements left out? AX, BY minus AY, BX. You got same thing. AX, BY minus AY, BZ. AY, BX. Understood, all of you? Yes or no? Am I audible, everyone? This is how you perform cross product, guys. If the vector is given in space, if it is given in plane, directly determinant you will do and you will write, right? But if it is given in space, in the first row, you will write unit vectors along x, y, and z. In the second row, you will write components of first vector. In the third row, you are going to write the components of second vector. Now, how to find direction of A cross B? Let us say this is A bar, this is B bar. So I want to do A cross B. So A bar is first vector now. So in the direction of A bar, I will place my right hand and curl the fingers towards B bar. So direction of thumb, where will it be, beta? Perpendicularly outwards. So you are always going to use your right hand. If I do B cross A, then first vector is B bar. So I'll place my right hand along B bar, curl towards A bar. Right? Direction of thumb is inwards again. Okay. So we are going to find direction of A cross B by using right hand. A bar cross B bar. Understood? Yes or no? Is that clear, all of you? Everyone? Now, just like we have relative motion in one dimension, in the same manner, we have relative motion in two dimension. So I'll discuss relative motion today, right? Projectile motion, what all things of motion in a plane are left out. I'll discuss those tomorrow. And I'll also complete the questions of motion in a plane tomorrow, guys. Okay. As I've said you, today will be a little bit of less time session, guys. Now, when we talk about relative motion in one dimension, how did we solve the questions? Again, whenever we are trying to analyze the situation with respect to one object, I will stop that object. What all quantities are there to that object, I am going to give it to the other object in opposite direction. So here we are going to have three problems in relative motion in two dimension. One will be river problem, other will be distance of closest approach, and third one will be the rain problem, guys. Okay. So anyhow, the logic in such questions is same again. What is the logic? Whenever two motions is there, analyzing two motions will be little bit difficult. So we'll try to solve it by writing with respect to one object, guys. It's called as relative. Two motions analyzing is difficult compared to analyzing one motion. So what I'll do, I'll stop one motion and I'll see with respect to the first object, how is the second object moving. This is called as relative motion again. Okay, so when I talk about relative motion in two dimensions, guys, same concept as we used in relative motion in one dimensions, right? With whatever respect we are solving the question, that we should stop. What all quantities are there to this, I'm going to give it to the other objects. In which direction? Opposite direction. Same logic we are going to apply, guys. Okay, is that clear? Yes, so I'm not discussing in detail about river problem and closest approach. However, when questions will come, I'll discuss those, guys. But the important case will be your crossing a river or river problem, guys. Rain problem, so you can do, and you can also do distance of closest approach. Although we will learn those in tomorrow's session. Now, river problem is very important. So let us say this fellow who is at A, he starts to swim like this with speed V. Okay, in order to reach the other shore again, and it is moving by making an angle theta with respect to vertical. What they are saying, time taken by the man to cross the river. So I am assuming that, can I resolve into two components? It's already resolved here, guys. Speed can be resolved into two components here. One is v cos theta, other is p sin theta. So in order to cross the river, should there be displacement in y direction or should there be displacement in x direction? In order to cross the river,
Y direction.
means it should be in y direction. Which components of velocities will be giving us motion in y direction? Y components only. X components will not help us out, guys. Okay. So what we can understand in this situation, man is trying to swim in this manner, right? Making an angle theta with the vertical, guys. So I've resolved this velocity in two components. One will be your v cos theta, other will be your v sin theta. Yes or no? Now, in order to cross the river, just now you said, which displacement it has to attain? It has to attain vertical displacement, guys. So who will be responsible for covering that displacement? Will v sin theta be responsible or v cos theta be responsible? See, what is v sin theta doing? V sin theta is taking the object towards left side along the shore. Is it helping the object to cross the shore? No. So who will help the object to cross the shore? Y component velocities. Here in this case, v cos theta will help you guys. So what is the time again? What will it be given as? How much distance it has covered? D distance. With what speed? V cos theta. Clear all of you? This will be the time of crossing. And during this time of crossing, there may be some horizontal displacement. So here in this case, what I'll write? V sine theta into t will be your horizontal displacement again. Clear all of you? However, if I say the river is also flowing, then please tell me x component velocity. So this is fixed. P cos theta I cap. What about y component velocity? Y component velocity here. Sorry, y component is only fixed. So what is x component velocity, beta? It is v sine theta minus j cap. Sorry, minus I cap. And what is v y bar in y direction? Is v cos theta j cap. Yes or no, all of you? So which component of the velocity is responsible for crossing the river? V cos theta. So we got time of crossing as d divided by v cos theta, guys. Now suppose uh, if the river is also flowing with some speed u, guys, then this person will have three components now. This is the case when river is not flowing. Here, if u is 0, suppose if u is not 0, then in that case, river usually flows horizontally only, guys. And how can I write x bar as x component velocity? I'll write it as u difference v sine theta I cap. Yes or no? Because it has now got u as well as v sine theta. Both are in opposite direction. Vertical component, it is still going to remain v cos theta only. Clear all of you? So which component is responsible for the river, for the man to cross the river? V cos theta. So in order to cross the river, how much vertical displacement it has to cover? D. So very important formula, time of crossing will be given as d divided by v cos theta. Clear everyone? Now, because u and v sine theta are not same, due to their resultant, there will be some horizontal displacement attained. And that horizontal displacement attained will be given as d by v cos theta into u minus v. Horizontal displacement will be attained by only horizontal components. What is horizontal component? U difference v sine theta into time you can write. Understood? Yes or no? Is that clear, all of you? So which component will be helping the man to cross the river? In order to cross the river, it has to attain vertical displacement. So vertical component will be helping. So time of crossing will be thickness of the river divided by v cos theta. Understood? In this, we have two cases again. So we got, this is called as drift also, guys. What is T here? T is the time of crossing. And what is D here, beta? D happens to be drift again. Okay. Drifting will be there if u and v sine theta are not cancelling out each other. If they both are equal, then there will not be any kind of drifting again. So we got to know time of crossing is d by v cos theta, and the drift attained will be d by v cos theta into u difference v sine theta we can write. Shortest time, it seems. So what is the meaning of shortest time? It means the denominator v cos theta should be maximum. So all the velocity should be along the, you can write minimum time of crossing. If I say, it will be given as d by v. So here, as I said, cos theta value will be 1, theta value will be 0. And how much difference will be attained? Distance it will be drifting, u into d divided by v. Clear? So what is time of crossing in general? I'll just prove it, guys. We got time of crossing as d divided by v cos theta. I want this to be minimum. For time of crossing to be minimum, can I say v cos theta should be minimum or not? Yes or no, all of you? Sorry, V cos theta should be maximum or not? Because it's present in denominator. So what will cos theta maximum value be? Cos theta maximum value will be plus 1. Where will it occur? It will occur at 0. It will occur at pi also you can take. So here what we can take beta? Theta value will be 0 degrees. Understood? Then you have something called a shortest path. Now the shortest path happens to be only width, guys. So for shortest path, drift should be 0. Very important case again. Right? We have two cases. One is shortest time, other is shortest path. In shortest time, how much should be uh, cos theta value? Maximum. So theta value should be taken as 0. Time of crossing will be d by v, and the drifting distance that will be drifted will be u into d by v, guys. But now if I want to cover or cross the river in shortest path, there should not be any drift, guys. Okay. And what will sin theta value be? It will be u divided by v. And what is the time taken to cross the river beta? D divided by under root of v square minus u square. Very important cases. In first case, what is the time taken? Generally, time taken to cross the river? D by v cos theta. What is the drift beta? Again, it is u difference v sin theta into time of crossing, which is d by v cos theta. Two cases are there. One is shortest time, other is shortest path. Shortest time means cos theta value should be maximum. Means our entire velocity should be along the vertical only. Okay. Then what will be the time in shortest time? D by v. And what would be the drift? U into d by v. Whereas in shortest path, drift should be 0, guys. So when drift is 0, how it should be swimming? He should be swimming at an angle sin inverse of u by v. Clear, all of you? And what will time of crossing be? D by under root of v square minus u square. V is the speed of the object. U is the speed of the stream. Clear, everyone? Yes or no?
Sir, can you explain sin theta part once again?
Huh?
Can you explain that sin theta part once again? That sin theta should be u by v.
No, yaar, drift should be 0, no? When will drift be 0? U minus v sin theta should be 0. So I'll get sin theta value as u by v. So sin theta is u by v means uh, what we can consider? Theta value will be sin inverse of u by v. So in order to cross the river in shortest path, the person has to swim at this angle. Theta is sin inverse of u by v. And the time taken in this path will be d by under root of v square minus u square. Clear?
Yes, sir, clear.
Right, so we have discussed regarding vectors as well as the relative motion. Right? In relative motion, three concepts are there actually. One will be your rain problem, distance of closest approach, as well as river problem. The first case, rain problem and distance of closest approach, can be done with examples maybe given tomorrow. We can do that. But river problem, important things you need to remember. What is the time of crossing? Which component is helping the object to cross the river? Right? Then what is the drift generally? There you have two cases again. One is shortest time and shortest path. Shortest time will be theta value 0. Shortest path will be drift value should be 0 or sin theta value should be u by v. Clear? Yes or no? Let me discuss horizontal projection, guys. So what is the meaning of projectile again? You take any object if it is either moving in plane or in space, right? Plane means 2 dimension. Space means 3 dimension, 4 dimension, 5 dimension, whatever it may be. So whenever an object is moving under the influence of gravity, whenever it is moving in plane or space under the influence of gravity, such object will be called as a projectile. The motion associated with such object will be called as projectile motion. Two things are very important. One is horizontal projection, other is oblique projection. Now, what is the meaning of horizontal projection? Here, object is given a speed horizontally from a certain height. Okay, so t is equal to 0. So as soon as it leaves this contact, will it be moving under the effect of gravity or not? Yes or no, all of you? So is there any acceleration in x direction? No acceleration in x direction. It means velocity in x direction will remain constant. So here also you will get u only. Here also you are going to get u only. Vertically, is there any initial velocity? No. But vertically it is moving under the effect of gravity. How much distance did it cover? H distance it has covered, guys. So what we can write here? You can write it as root over 2gh. Clear? In the same manner, at any intermediate instant, guys, horizontal component, so everywhere it will remain same only, right? But vertical component will become gt. How will you find speed at any instant? At that particular point, just draw a tangent beta. This will give velocity at any instant, and this will give us the velocity with which it is going to hit the ground. And in this case, range will be given as, again, you need to remember the formulas, guys. Range will be given as u into root over 2h by g, right? The time of flight will be given as root over 2h by g. Range will be given as u into root over 2h by g. Now, I want to find final velocity. It has two components or not? Ui cap plus root 2 gh minus j cap. So because they have two perpendicular components, what will speed be? Under root of u square plus minus root 2 gh whole square. So what will I get? U square plus 2gh. So this is the speed with which it is going to hit the ground. And what would be speed at any instant, beta? Speed at any instant if I take, it is ui cap plus gt is in which direction? Minus j cap. Clear, everyone? Yes or no? So please remember range formula in this, time of flight formula in this, guys. Speed with which it is going to hit the ground, speed at any arbitrary position also. Understood? So please remember these formulas: time of flight, range, right? Then what, with what speed is going to hit the ground, with what speed it will be moving at any instant. How will you find speed? Again, just directly draw the tangent, guys. Clear, everyone? Yes or no? The rest of the part of projectile motion we'll be seeing tomorrow, right? Apologies from my end because tomorrow is festival. I am preoccupied with a lot of work, guys. But I thought I should definitely teach something today. So I have given a review of scalars, vectors, relative motion in 2 dimension, and one case of projectile motion. Clear, everyone? Whatever we have discussed, is it clear, everyone?
Yes, sir.
Right, I hope it is clear, guys. Okay, now what I'll do is, because you have completed some chapters, guys, I said that I'm going to post some questions, right? I'm not saying everyone to do those questions, but who are willing to score more in physics, those people can solve the questions, guys. So within 5-10 minutes I'll post that questions. You can try doing those questions. Okay, is that clear? Right now I have to end the session. Tomorrow will take 2 hours in the evening. Sunday will take in the morning, maybe 3-4 hours, something like that. Okay, clear, all of you? Is that clear?
Yes.
We'll meet tomorrow, guys. Then take care, everyone. Thank you all.
Thank you, sir.
Thank you.
Thank you, guys. Take care.